For years, astronomers believed they understood the early universe. They thought they knew how galaxies were born, small, chaotic clusters of stars slowly assembling over billions of years. But that belief began to crumble the moment the James Webb Space Telescope pointed its golden mirrors toward the deepest, oldest corners of the cosmos. What it found there didn't belong to any textbook, any model, or any accepted timeline. Instead, it revealed a cosmic contradiction so unsettling that many scientists struggled to speak about it openly. Because hidden inside the faint glow of ancient starlight was something that should not exist, something that challenges the universe's official story. It began quietly, almost innocently, with a batch of early JWST observations. Among the expected tiny smudges of primordial galaxies, researchers noticed objects that looked wrong. Not small, not young, not primitive, but large, structured, mature, as if billions of years of cosmic evolution had somehow happened while the universe was still in its infancy. These galaxies shone too brightly, weighed too much, and appeared too organized for the era in which they were found. And when the distances were calculated, the truth hit with the force of a silent shockwave. These objects were ancient, older than the universe should have allowed them to be. Nearly 8 billion years worth of evolution appeared compressed into a window of cosmic history where only the earliest baby galaxies were expected to exist. Something was off, terrifyingly off. One researcher who analyzed the data was the first to whisper the word, impossible. She expected the telescope to show crude clusters of gas, building blocks, nothing more. But instead, she found disks, bulges, rotation curves, even hints of early spiral arms. Features that require countless cycles of star formation and gravitational organization. Features that simply could not emerge so early in the cosmic timeline. She tried to recalibrate the calculations. She redid the models. She rechecked the redshifts. But the galaxies remained where they were, too bright, too big, too old. Every attempt to force the observations into the existing cosmological framework ended the same way, with equations breaking apart under the weight of reality. Quietly, other scientists began to notice the same distortions. Emails appeared in inboxes at 2 in the morning, filled with nervous questions and hesitant speculation. Some researchers wrote cautiously, tiptoeing around the implications. Others abandoned caution entirely, confessing that the data made their skin crawl. These weren't amateurs or sensationalists. These were astrophysicists who had dedicated their lives to understanding the universe. And yet, they all confronted the same silent truth. These galaxies shouldn't be there. If they existed this early, then the universe was not the place they thought it was. Over the following weeks, the anomaly grew. More galaxies were found, larger, brighter, older in appearance than anything predicted for that cosmic era. The number of impossible structures increased until the word impossible lost meaning. Instead, researchers began using terms like premature, overgrown, and non-conforming. Not because the galaxies were flawed, but because the theory was. Every discovery added pressure to a timeline already stretched to its limit. The most chilling part wasn't the galaxies themselves, but what their existence implied. To look at them was to see a universe that evolved at a pace far beyond what scientists believed possible. A universe that seemed to have sped through its earliest stages as though following a hidden set of rules. Rules no one had accounted for. Rules no one had even suspected. At conferences and behind closed doors, researchers debated the implications. Some argued for exotic dark matter behavior. Others suggested new laws of physics. A few whispered about the possibility that the Big Bang timeline was incomplete. But none dared say the words publicly, not yet. Not without understanding what, exactly, they were witnessing. Because the deeper they dug, the stranger the mystery became. A cosmologist studying the metallicity of these galaxies discovered something even more unsettling. These ancient objects contained chemical signatures that should have required generations of dying stars to produce: iron, oxygen, elements that take time to accumulate. But time was the one thing the early universe didn't have. These galaxies behaved as though they were billions of years old, billions of years before they were supposed to be. Another team found something else, an anomaly hidden in the cosmic microwave background. A faint, delicate distortion that didn't match known patterns. Not noise, not error. A trace, a fingerprint, something older than the galaxies themselves, yet connected to them. When one of the scientists first saw it, he reportedly sat in silence for several minutes before asking a single question. What existed before this? No one had an answer. But the more they looked, the more it felt as though the universe were offering clues, subtle at first, then increasingly bold. Something had left marks across time, across structure, across the fabric of existence itself. Marks that only became visible now, with Webb's unmatched clarity. Some researchers proposed that the universe may have expanded faster than expected in its earliest moments. Others wondered whether unknown processes allowed matter to clump together more rapidly than predicted. But each explanation only raised more questions. Why this fast? Why this early? Why this organized? Why now? The galaxies refused to fit the model. The model refused to fit the universe. And yet, with each new observation, the pattern grew more undeniable. These objects weren't aberrations. They weren't accidents. They weren't statistical outliers or miscalculations. They were evidence. Evidence of a universe with a past deeper than its timeline suggests. Evidence of processes still unknown. Evidence that the comforting story of cosmic evolution told for decades might be missing entire chapters. Scientists tried to stay calm. They tried to adapt the models. But each attempt only widened the gap. Every corrected equation, every updated simulation, every reinterpreted dataset cracked open a new inconsistency. It was like trying to repair a puzzle, only to discover the pieces came from a different picture altogether. In the midst of this unease, a quiet realization began to spread through the scientific community. A thought no one wanted to voice, but no one could ignore. What if the universe had a beginning, but not the beginning we think? What if something existed before the earliest detectable moment? Something that shaped the timeline? Something that set the stage for galaxies to form before they should? Something woven into the cosmic background, too faint to notice, until now? Whatever the explanation, one truth became impossible to deny. The James Webb Telescope had revealed more than galaxies. It had revealed a crack in the universe's origin story, a fracture reaching back across billions of years, connecting the present to an age beyond understanding. And behind that fracture, something waits. Not a conspiracy, not a cover-up, but a truth older than the universe we know. A truth the galaxies have been trying to tell us since the beginning. And now, finally, disturbingly, we're starting to hear it. And this is where the story deepens into something far stranger. As weeks passed, the scientific community found itself caught between fascination and dread. The galaxies revealed by Webb were no longer isolated anomalies. They formed a pattern, an undeniable trend carved across the early universe like a message in ancient stone. The more researchers tried to explain them, the more the explanations unraveled. The universe, it seemed, wasn't simply bending the rules. It was rewriting them. The new data forced astronomers to re-examine every assumption about cosmic infancy. They analyzed star formation rates, gravitational collapse models, dark matter distribution, even the behavior of exotic particles. But nothing fit. Nothing explained how massive, mature galaxies could exist so close to the supposed beginning of time. And while some were excited by the implications, others felt something far heavier, a sense that they were approaching a wall in human understanding, an edge beyond which current science could not safely step. Behind the scenes, quiet conversations took place in research departments and observatories. No one wanted to be the first to suggest that the timeline of the universe itself might be inaccurate. But no one wanted to ignore the evidence either. One astrophysicist put it best during a late-night discussion when she whispered, "This isn't a crack in the model. It's a doorway, and I'm not sure what's on the other side." Around this time, a new kind of anomaly emerged, one that didn't come from galaxies at all. Instead, it came from the empty spaces between them. Webb's instruments detected unusual fluctuations in the faint glow that fills the cosmos, the cosmic infrared background. These fluctuations were subtle, almost ghostly, but too consistent to dismiss. They hinted at structures that predated even the earliest visible galaxies. Structures that seemed to echo across the fabric of space like distant footsteps from a time before time. A team studying the fluctuations noticed that they aligned eerily well with the positions of the overgrown ancient galaxies. It was as if the galaxies were forming along invisible scars in the universe, scars that shouldn't exist. Scars left by something older, something powerful, something that shaped the cosmos before the cosmos was even supposed to exist. Some researchers called it a coincidence. Others privately admitted that it felt more like a signature. And that's when the unsettling question began circulating among scientists. What came before the observable universe? For decades, the answer was simple. Nothing measurable, nothing detectable, nothing at all. But the anomalies forced them to reconsider. If something left marks on the earliest galaxies, then something must have come before. Maybe not a previous universe, but perhaps a phase, a hidden era beyond the Big Bang's radiant veil. An era whose traces were never meant to survive. Yet somehow, impossibly, they did. The more scientists searched, the more strange correlations they found. Patterns in the cosmic microwave background that were once dismissed as noise now seemed suspiciously organized. Ratios in early galaxy mass that matched no known formation mechanism. Star populations that were too chemically evolved to belong to such a young universe. And whispers from gravitational wave detectors suggesting the presence of colossal structures that formed impossibly early. But amid all the hypotheses, one stood out, quiet, elegant, and haunting. The idea that the universe underwent a rapid, violent expansion much sooner and much faster than even inflation theory predicts. Faster than physics should allow. So fast, in fact, that the earliest structures formed in an entirely different regime of the universe. One not governed by the rules we know. A pre-cosmic environment, a phase older than the Big Bang as we understand it, a place where galaxies, or at least the seeds of galaxies, could have begun forming long before the universe reached the stage where we can observe them. Some scientists now suspected that those seeds survived the transition into our observable universe, carrying with them the fingerprints of a forgotten era. If true, it would mean that the galaxies Webb detected weren't anomalies, they were relics. Fossils of a time we cannot yet imagine. Evidence of something bigger, older, and deeper than everything written in our cosmological textbooks. But even this idea came with problems. If pre-Big Bang structures existed, why were they arranged the way they were? Why did they form in patterns that stretched across billions of light years? Why did their fingerprints align so precisely with the positions of early galaxies? And what mechanism could possibly bridge two eras of existence divided by a cosmic rebirth? No one had answers, but everyone had theories. One physicist suggested that spacetime might carry memory, residual imprints from previous cycles of existence. Another proposed that quantum fluctuations in a pre-universe environment could have collapsed into structures that survived the transition into ours. A third dared to ask whether something conscious, or at least self-organizing, could have played a role. That idea was dismissed immediately, yet it lingered, heavy and uncomfortable, as if it had been waiting to be spoken. But the most unsettling hypothesis came from a researcher who had spent decades studying the cosmic background. He published a short, understated note pointing out that the distortions Webb detected weren't random. They were directional. They formed a map of sorts, one that seemed to trace a history much longer than the universe's accepted age. If his interpretation was correct, the anomalies weren't isolated. They were connected, and if they were connected, they formed a structure so vast and complex that it dwarfed anything humanity has ever imagined. A structure woven through time itself. This possibility spread through the community like a quiet shiver, not because it implied a conspiracy, but because it implied something far more profound: that the universe has depth. That its history extends beyond its beginning. That its oldest features are not early, but inherited. That we are witnessing the remnants of a forgotten chapter, one that left its imprint across the cosmos and waits for us to uncover it piece by piece. As these discussions unfolded, new observations pushed the mystery even deeper. One galaxy in particular drew intense attention, a massive, bright object that appeared in an era where it simply should not exist. The light from this galaxy had traveled nearly the entire length of cosmic history, yet the galaxy itself looked astonishingly mature. Its stars were old, its structure was refined, its mass was enormous, and every measurement confirmed that it formed far too early for any known process to explain. A researcher analyzing the galaxy's spectrum noticed something alarming. The distribution of elements inside it didn't match the expected pattern for early galaxies. Instead, it resembled the chemical makeup of galaxies billions of years older. As if time itself had folded in on the object. As if it had lived an entire unseen history before the universe was ready for it. And again, the same theories resurfaced: parallel formation epochs, accelerated structure growth, pre-Big Bang remnants. Each one stranger than the last, yet none felt more absurd than the idea that these galaxies should not exist at all. Because there they were, shining confidently across the cosmic darkness, indifferent to human confusion. As scientists grappled with the implications, a new realization emerged: quiet, simple, and devastating. The issue wasn't that these galaxies were too old. The issue was that our understanding of age might be wrong. Perhaps the universe has layers of time we cannot yet perceive. Perhaps cosmic evolution did not begin with a single event but unfolded in phases, each leaving marks that bleed into the next. Perhaps the Big Bang was not a beginning, but a transition. This thought unsettled many, not least because it forced them to reconsider their place in the universe. If the cosmos had existed in forms beyond our comprehension, then humanity was not witnessing the beginning of everything, but rather, the latest chapter in an ongoing story. A story older than galaxies, older than light, older than the laws of physics themselves. By the time the scientific community acknowledged the seriousness of the anomalies, the mystery had deepened beyond simple explanations. The galaxies were not just early, they were clues. Clues that pointed toward a hidden past, a buried era, a cosmic ancestry that current physics could barely begin to describe. And as new data continues to arrive, one thing becomes increasingly clear. The universe is not the naive, young cosmos we once imagined. It is older, stranger, and far more layered than we dared to believe. The galaxies shining from the edge of time are not mistakes. They are messages, reminders that the universe has secrets it is finally, reluctantly, beginning to reveal. And those secrets are only growing louder.